here, what's going to end up happening is by increasing that temperature, you're breaking the lattice, okay? So you're basically taking and breaking that lattice of the silica chains, and what ends up happening is the rock melts. So it's common sense to say that as I increase temperature, the rock is going to actually melt. That will generate magma, okay? But now you've got to look at the other thing. Whenever we start to go too deep, what happens is not only is the temperature increasing, but also the pressure is increasing. And because you have that pressure increase, what ends up happening is it ends up keeping those chains bonded together. So it actually, the deeper it goes, it makes the rock harder to melt. Okay? So that's one of the things that you have to look at there. You have to say, wait a second, I can increase the temperature and melt the rock, but if I go deeper and deeper into the Earth's crust as like a subduction zone, the pressure is going to hold this thing together. Now, we're going to actually get a better understanding of this. I've got a little video or a diagram that'll show you how this actually works. Okay, so that's one thing. Now, looking at the diagram at the right, here's the other thing that you can look at. Whenever we have magma basically coming up through the surface here, what's going to end up, or up through the crust, excuse me, up to the surface, what can end up happening is some of that liquidous part can actually melt surrounding solid rock and incorporate it into the magma. So you can get actually just by coming in contact with, you can generate magma itself as well. So you can make more magma, which of course is going to make igneous rock in the later stages. So, all right, whenever you start looking at how does this actually work, we've got temperature, okay? Temperature, increase the temperature, we can melt and make magma, which of course then later can become igneous rock. But you've also got to look at this actual pressure relationships. Whenever you start talking about pressure relationships and the melting, it's really kind of odd and it's a little tough to understand. So, here's what you've got. This is called decompressional melting. Basically what you're looking at here is you can see decompressional melting. It's when solid mantle rock is actually moving upwards. So what you'll see down here is you'll see this rock moving upwards. Well, as it moves upwards, the pressure is decreasing. Well, once you decrease that pressure, what ends up happening is it's still hot. That magma is hot. Okay, so what you've done is you've taken somewhat of a solid material down here that, and it's really kind of confusing here, but you've got this solid material moving up, and as you take the pressure off, it causes the rock to actually melt. That's called decompressional melting. Okay, and once you have that decompressional melting occur, boom, magma is generated. All right. Another thing that we can look at, another factor that can influence the melting of rock is by adding volatiles or water. Okay, as you can see over here in the diagram at the top, you're going to have this subduction zone. So you've got the oceanic crust subducting beneath the continental crust, and as it goes down and actually is subducted beneath, that causes water to be released into the surrounding rock. So you're adding water to this surrounding rock. And by adding that water, what you're doing is you are lowering the melting point. And by lowering the melting point, you actually, because of the intense heat, you are now going to cause that rock to melt. Okay? So as you can see right through here, the rock is melting. And then, of course, because it is less dense, it's going to rise up through the crust. And, of course, it's going to eventually crystallize, making our igneous rocks. Okay, so whenever you start looking at this process where you have what is called wet melting is whenever water is added to rock, and it's very common along convergence zones. Okay, so here we go. Let me show you how this actually works. First, we're going to look at decompressional melting. As you can see the asthenosphere, the ascending mantle, is because it's hot and less dense, it's going to rise. As it starts to rise, the pressure decreases, and that pressure decreases causes melting to occur. And of course, we have magma generation. And then that magma is, of course, going to, once it reaches a different environment, it's going to crystallize, making igneous rock. You look over here, this is going to be wet melting. As you can see, the subducting plate has water in it because it is the oceanic crust. It's going to go down, it's going to release the water into the surrounding rock, and it's going to, increase its temperature as well. And then what ends up happening is by the addition of water, that lowers that melting temperature, magma is forming, and then because that magma is less dense, it's going to rise to the surface, and of course it's going to crystallize and make igneous rock. Okay, so now we've got three different variables. We've got temperature. By increasing the temperature, you can originate magma. By decreasing the pressure, you can originate magma. And then, of course, by adding volatiles, you can generate magma. But now you're looking at the last thing, composition. Whenever we start looking at composition, you've got to look at the order of crystallization, okay? So this is more like you're taking a rock that has like all of these minerals, okay? This is going back to our minerals section here. But you're looking at what is called Bowen's reaction series. Here's what's going to happen, okay? Minerals do not melt in the same order that they actually crystallize. So whenever you look at a crystallizing melt, as you guys can see here, the crystallizing melt is going to be like it's hot and it's going to get cooler. Well, the first thing that happens is olivine comes out of it, and you've got olivine. And then olivine reacts with the remaining melt, and then you get pyroxene. And then you keep on going, and all these minerals crystallize out. Well, now just imagine we have a rock, just because, that has all of these minerals in it. Okay? Well, what's going to happen is the order of melting is going to be in reverse order. So you're going to look at all of these three minerals, the potassium feldspar, the muscovite mica, and quartz. They're going to melt first. Okay? And then, so now you've got this melting, and then you've got your biotite micas melting, the amphiboles, the pyroxene, the calcium rich, and then the last thing to actually melt is going to be the olivine. Okay? So simply by looking at what's the composition of rock, you can predict what order these things are going to melt in, and then you're going to be able to say, okay, I'm going to get this type of magma. And you'll get a better understanding of that with not only this unit, but with the next unit of volcanoes. Okay, so let's look at some actual environments where you can get this different type of melting where you're going to be forming igneous rocks. Okay, the first type here is a divergent boundary. Divergent boundaries, as you remember from chapter 2, or from our second talk, is basically going to be pulling apart. Okay, whenever you start looking at this, what you can notice right here is you have the ascending magma coming up. It's going to be somewhat solid portion, but because you decrease the pressure, you end up generating magma through decompressional melting. At convergent boundaries, you're going to basically be looking at the more dense oceanic plates subducting beneath this. Due to the high water content, you're going to be releasing water into the surrounding rock, and you're going to generate magma through the process of wet melting, so through the addition of volatiles. And then whenever you start looking at this, what you're doing is you can combine both types of melting here, because as this rising magma comes up, it's going to stall at the base right here. So what you can do is you can actually be increasing the temperature of this rock right here, which could incorporate this into the already pre-existing melt. So you can increase the temperature. Well, of course, as you ascend up towards the mantle, what's going to happen? You're decreasing, or from the mantle up towards the crust, you're going to decrease the pressure, and then you have decompressional melting. Okay? And then, of course, this is what you're looking at. It's mostly decompressional melting that's taking place along hotspots. Okay, so that concludes the lecture on the origins of magma. Our next lecture, as you can see, is going to be on the formation of igneous rocks.